Assalamualaikum and a very good day to all of you. This is Lecture 9 video lessons. Today I will teach you about spanning tree protocol concept. So first part of the video I will explain about the purpose of spanning tree protocol. So before we learn about the STP, let us understand the concept of redundancy in layer 2 switch network. So basically, redundancy is a very important part of the hierarchical design to eliminate single points of failure and at the same time to prevent a disruption of service in the network. So redundant network is very important. And how can we say that we have a redundant network? We can say that we have redundant network which when you have additional path to go to the destination. So because of this, redundant network require the addition of physical path, but they also require logical redundancy, which is part of the design. So for example, in this diagram, you have two PC, which is A and B, and then we also have three switches. So to say that we have a redundant network means if we would like to send a packet from PC A, you may have an alternative path to go to the PCB. So you can either use or you add additional link for creating a new path to the destination. So having an alternate link or alternate physical path for data to traverse the network makes it possible for users to access network resources despite path disruption. Say for example, if this path fails, so you still have another route or another path to go to the destination. However, redundant path in a switched Ethernet network may cause both physical and logical layer loops. So what it means by loops? So basically, loop means that frames is loop in indefinite period of time in Ethernet network with physically redundant link. For example, if all path works in this example, so there are possibilities that the frame will be forwarded back to PCA. So in this case, it or not to the PCA but looping between the switches. So in this case, we could say that having a redundant path will also create looping frames. So to prevent looping frames, so we need some mechanism to block some ports from forwarding frames so that only one active path exists at one time between any pair of LAN segment. So this is where spanning tree protocol comes into the picture. So spanning tree protocol or STP is a loop prevention network protocol that allows for redundancy while creating loop-free layer 2 topology. So what happened here is if you have a redundant network, so STP, like in this case, you have two paths to go to PC4. So what happened here is STP will logically block physical loops in layer 2 networks and preventing frame from circling the network forever. So STP compensates for a failure in the network by recalculating and opening up previous block ports. So for example, we know that we have two paths, and previously we have blocked trunk 2, a port on trunk 2. So if the link for trunk 1 eventually fails, so the STP will automatically calculate and opening up the previously blocked port so that packets from PC1, PC2, PC3 will or can be forwarded to PC4 using trunk to link. So there are some issues with redundant switch links. Okay, the first one is path redundancy provide multiple network services by eliminating the possibility of a single point of failure. So when we have multiple paths between two devices on the network, so there is, and if we have no spanning tree on the switches, so layer 2 loop will occur. So when you have a layer 2 loop, so it could result in MAC address table instability because the switch keep adding and learning MAC address into their MAC address table, and there will be a problem of link saturation and high CPU utilization because the flooded frames would loop for an indefinite period of time in the network. So basically, layer 2 Ethernet does not include a mechanism to recognize and eliminate endless looping frame. Hence, the reason, but if we look at a layer 3 device, okay, so both IPv4 and IPv6, there is a mechanism that limits the number of time a layer 3 networking device can retransmit a packet. So layer 2 does not have that mechanism. In layer 3 device such as router, so we have the time to leave, the TTL mechanism in every IPv4 packet that will limit the forwarding of the packet. So when the field are decremented to 1, so our router will automatically drop the packet. So STP is developed specifically to prevent looping in layer 2 Ethernet. So when loops happen, when layer 2 loops happen, so it will cause the broadcast or unknown unicast frame to loop endlessly, and this could brought down the network immediately. So what happened here is when a loop occurs, the MAC address table on a switch will constantly change with the update of for the broadcast frame. So basically this will result in MAC address database instability and cause high CPU utilization because keeps forwarding the frame for indefinite amount of time. So basically, when we have STP, frames will not loop infinitely and it will make the LAN usable. Okay. So when the frame is, or when there's a high numbers of frame looping in the network within indefinite time, so this is what we call as broadcast storm. So what is broadcast storm? Broadcast storm is abnormally high number of broadcasts overwhelming the network during a specific amount of time. So basically it can be caused by a hardware problem or a layer 2 loop in the network. So there are two reasons, because of the hardware problem or layer 2 loop in the network. So basically for layer 2 broadcast in a network such as ARP request, because we know that ARP request requires a layer 2 broadcast. So basically if there is the environment is not loop tree or STP is not enabled, so the frame will be forwarded throughout the network. So basically you need to understand that when a host caught in a layer 2 loop is not accessible to other hosts on the network, and in addition, there will be a constant changes in its MAC address table because of why when because the switch does not know out of which port to forward unicast frame. So because of that, we need some mechanism, and I already explained again, the mechanism is having a spanning tree protocol. Now, by default, okay, Cisco IOS based LAN switches or Cisco switches enable spanning tree protocol by default on all interfaces in every LAN or every VLAN to prevent layer 2 loops from occurring. So basically, you won't even realize, or you won't even need to enable STP on Cisco switch, because it is enabled by default to prevent layer 2 looping. So STP is actually based on algorithm which is created in 1985. So what happened here is to create a loop-free topology, the idea here is we need to select a single root bridge where all other switches determine a single least cost path. So we need to do two things. If you have alternate path and you have more than one switches to go to forward the frame to the destination, so basically what the SDP will first select a single root bridge, and the other switch that is not becoming a root bridge will determine the single least cost path. Okay, but I will explain in detail the implementation of SDP in the next video. But what most important in SDP is it will create a loop-free path by strategically place blocking state ports based on the calculated path cost. So basically, this is the idea, which is SDP will automatically or strategically place a blocking state ports on the non-root bridge according to the algorithm. So in the spanning tree protocol, there are few steps for the spanning tree protocol to create a loop-free topology. First, they will select a root bridge, and then they will block redundant path, and then they will, if there is a failure, on the forwarding link, the current forwarding link, so they will this app recalculate in case of link failure, recalculate and unblock the previously blocked port. Of course, you don't really understand now because I will explain in details in